Let's continue with our lecture series on NEET PYQ. This is our second lecture on work power energy. Let's start with our first question. Our first question says the body of mass 4m. Body of mass 4m is lying in xy plane at rest. So initial velocity is 0, fine. It suddenly explodes into 3 pieces, fine. So let's say this is our object and it's exploding into 3 pieces. First piece, second piece and third piece. Okay, fine. Two pieces each of mass m move perpendicular to each other. So let's say this is of mass m. This is also moving with mass m, but in perpendicular to the first one. So this is m moving in perpendicular direction with equal speeds v. Let's say this is moving with speed v and this is also moving with speed v. The total kinetic energy generated due to the explosion will be how much, right? Understood? So let me explain you the problem in a simple language. This is our, let's say this is a rock. Okay, this rock is getting split into 3 pieces, out of which 2 pieces are moving perpendicular to each other. So if it is along x-axis, this will be along y-axis. You can take even yz or you can take zx, right? We don't know what is the velocity, but we know what is the value of mass of the third one, right? So if this is of mass 4m, if this is of mass 4m and this is of m and m, then obviously this will be of mass 2m. Let me repeat again. If the initial mass of the rock is 4m, then the rock will get splitted into m, m and 2m, right? Why it is 2m? Because both of them are 2m and m, right? So when you add all the masses remains conserved, right? Okay, let me come back here. So let's say this is moving along x-axis, so I cap, this is moving along y-axis, so j cap, right? By law of conservation of momentum, the total momentum of the whole system remains conserved. And what is the total momentum? So initial momentum is 0. So the final momentum, or let me write it into different steps, pi. Pi is the total initial momentum must be equal to the total final momentum. This is law of conservation of momentum, right? So pi here is 0. Why? Because the object was at rest. Okay. Pf, here this will be mv I cap. This is mv j cap, mass into velocity j cap. And this will be 2m, and we don't know what's the velocity of this. So let's call it as v dash, right? We are actually looking for the magnitude of this v dash so that we can find the velocity, right? Okay, let's take, let me first divide the whole equation with m. So it will be 0 equals vi cap plus vj cap, and this will be our 2v dash, right? Let's take it on the left hand side, minus vi minus vj, and that will be equals to whole divided by 2 equals to v dash, right? So this is our velocity vector of our final piece of this particular object, right? Now if this is the velocity vector, we can find the magnitude of this, and magnitude of this will be how much? Root under, this will be v square plus this will be v square, and that will be how much? 4, correct? Okay, you can call it as v square by 4 plus v square by 4. I hope this is clear. Now that will be equals to the magnitude of v dash, right? And v square plus v square is nothing but 2v square, and 2 and this 4 will cancel out. We left with v square by 2. So the magnitude of the third piece, the velocity of the third piece will be equals to how much? Under root v square by 2. Let me clear. V square plus v square is 2v square, and that 2 cancels out with 4. So this gives you v square by 2 magnitude, right? And that will give us v dash will be equals to v by root 2. This is the velocity of the third piece, right? Now we got the velocities of each one of them, the magnitude. Why we are looking for the magnitude? Because kinetic energy is a scalar quantity, right? We don't care about the directions. So let me remove this whole part. I hope this is clear that how we got our, and in case if you are not clear with that how we apply conservation of momentum, you can watch the previous lectures of laws of motion, right? Their link is in the description. So let me come back to the problem here. The total kinetic energy will be equals to half m first particle with the velocity square. Sir, we will write j cap? No, it's a magnitude because it's kinetic energy, right? Plus the total energy of the second particle, which will be half m v square. I hope this is clear. What about the third one? So third one will be equals to half. What's the mass? So 2m. And what's the velocity? So velocity is over here. We will square it. It will be v square by 2. Correct? Let's cancel out this 2 with 2. And let's take half mv square common. Taking half mv square common, we left with here 1. Here we left with 1. And here also we left with 1. So this will be equals to 3 by 2 mv square. I hope this is clear. So is there any option? Yes, option B is correct for this particular problem. It's 3 by 2 mv square. Clear? Let's see the next question. Great. Our next question says an engine pumps water continuously through a hose. Now hose is basically a pipe. Okay, let's call it as pipe. Okay. Water leaves the pipe with the velocity v. Okay, and mass m is the mass per unit length. Be very careful. M now is mass per unit length, which is m by L. Fine. M here is mass per unit length. So what is the actual mass? Sir, actual mass is M, that is equals to M into L. Be very careful with this. The actual mass which is transferred will be mass per unit length into the length of the pipe, right? Okay, fine. Of the water jet. What is the rate at which the kinetic energy is imparted to the water? Okay. So rate is simply kinetic energy per unit time. I hope this is clear. The rate is simply kinetic energy per unit time. Now what is kinetic energy? Sir, kinetic energy is nothing but half capital M I am putting. Sir, why? Because in this case, capital M is the actual mass. Small m is the mass per unit length. So it is half m v square, correct? Per unit time. That's the rate. Okay, fine, sir. No issues in this. And what about m? Sir, m is nothing but small m into L into v square by t. I hope this is clear. Now, amount of here, L is the length and T is the time. Length per unit time, distance per unit time, that's velocity. So, we can write here as half m v into v square. So, that will give you half m v cube, correct? Be very careful here, small m is not the mass, it's mass per unit length. So, we are expressing this formula in terms of mass per unit length. Many students will comment, sir, why, how you got kinetic energy is half mv cube? It should be half mv square. Yes, but here m is mass per unit length. Be very careful with this. So correct answer is option D. Let's see the next one. So our question says a shell of mass 200 grams, ms is equals to 200 into 10 to the power minus 3 kgs, right? Because it's in gram, is ejected from a gun of mass 4 kg. So mass of the gun here is mg will be equals to 4 kg. Fine. Okay, great. By an explosion that generates energy, the total energy here is 1.05 kilojoules. Be very careful. This K means kilojoules, 10 to the power 3 joules. Okay, fine, sir. Find the initial velocity of the shell. Okay, to figure out the initial velocity of the shell, what we will do here is we will apply the law of conservation of momentum, and it says the mass of the shell into velocity of the shell will be equal to mass of the gun into velocity of the gun. Let's find the unknown velocity of the gun equals to ms vs upon mg. Now the question is, sir, why you are looking for the velocity of the gun if the velocity of shell is asked, right? So that we will make use for the substitution. Okay, and substitution where, let's see this. So total energy here will be equals to half mass of the shell, velocity of the shell square plus half mg vg square. I hope this is clear. Here it is. Yes, this is the total energy, kinetic energy. Now what we will do, we will substitute the value of Vg here. Okay, so E will be equals to half m s Vs square plus half mg, and what's our Vg? Vg is our ms Vs upon mg whole square. Clear it is? Okay. Now let's expand it and simplify it. So let me do it over here. So E will be equals to half msvs square plus half, let's cancel out one of the mg with one of the mg, we left with here ms square vs square upon mg. Clear it is? Mg cancelled with one of the mg and ms vs square. Clear it is? Okay, let's take common out here. So E will be equals to half ms vs square. What we left with here? So nothing, 1. Here, sir, half is already out, 1 ms is left, vs is already out, mg is left. Okay, great. Clear it is? Now let's substitute the values and figure out the what? Unknown, the velocity of the shell they are asking, right? So E is nothing but, we have written 1.05 into 10 to the power 3 half, what is the mass of the shell? 200, and let's make it 0.2, that will be better, and velocity s square we don't know. Okay, up till here I have hope this is clear. 1 plus, what is the mass of the shell? 0.2, mass of the gun 4 kg. I hope this is clear. Let's take it on the other side. So taking this 2 cancels with 0.2, you left with 0.1, taking 0.1 that side, 1.05 into 10 to the power 3 whole divided by 0.1, that's equals to vs square into 4 plus 0.2, 4.2 by 4. Clear it is? Let's cross multiply. So vs square will be equals to 1.05 into 10 to the power 3 into 4 whole divided by 0.1 into 4. I hope this is clear. Clear it is? Okay. Now let's simplify it further. So this will be removing this 4. Let's cancel out it. 2.1 and 2 clear it is. And is there anything cancelling out further? Let's remove this point. We got here 10. Okay, fine. And you left with, let's remove this point. We left with an extra 10 here. And let's remove this. We got 100 here. Let's cancel out this 100 with this 100. And we left with 105 upon 21. So 21, how much it is? 21 fives. Correct? 21 fives are 105 and 5 twos are 10. So 10 into 10 to the power 3, 10 to the power 4. That's Vs square. Correct? Now Vs is nothing but 10 to the power 2, which is 100 meter per second. Is there any option? Yes, option C is correct. I hope you are clear with this particular concept. Let's move to our next question. Great. Our next question says a bomb of mass 30 kg. So mass of the bomb is 30 kg. At rest explodes into two pieces. One piece is M1, 18 kgs, M2, 12 kgs. Great. The velocity of 18 kg is 6 meter per second. Fine. The kinetic energy of the other mass. So you have to find the kinetic energy of the other mass. To find kinetic energy, again we will apply same the law of conservation of momentum and find the velocity of the second particle, right? So it was at initially rest. So we will make use of concept of momentum. Initial total momentum must be equal to the final momentum, correct? And initial momentum is 0 because it was at rest. Final momentum, mass of the first particle 18 kg, or let me just write the expression first, m1 v1 plus m2 v2, correct? I hope this is clear. And what is our m1? So m1 is 18 kgs moving with 6 meter per second. Clear? m2 here is 12 kgs and we don't know the velocity v2. Taking it that side, minus 18, so we don't care about the negativity, that's just a direction, v2. Clear it is? Let's cancel out 6 2s and 2 9s. So velocity of the second particle is, magnitude is 9 meter per second. I hope this is clear. This is the magnitude of the second particle velocity. Great. If this is the velocity, the kinetic energy of the other mass. So we have to find the kinetic energy of this particular mass. So kinetic energy will be equals to half second mass, which is 12, and velocity square, which is 9 into 9. 2 6 and 6 9s are 54. 54 into 9, that will be 36. 3 9 5s are 45 and 3 48. 486 joule. Is there any option? Yes, option B is correct. I hope this is clear, right? Very simple, straightforward problem. Let's see the next question. Great. Next question says a particle of mass m1 is moving with a velocity v1. Beautiful. And another particle of mass m2, okay, is moving with a velocity v2. Both of them have the same momentum. So both of them has same momentum. P1 equals to P2. M1 v1 is equals to M2 v2. This is the conclusion we made on this statement. But the different kinetic energies are E1 and E2. Okay. If M1 is greater than M2, M1 is greater than M2, then which one is true? Clear? Now we know that kinetic energies are different and momentum are same. So first let me write the relation between kinetic energy and momentum. So E equals to P square by 2M. I hope this is, you are familiar with this expression, right? Okay. Kinetic energy is P square by 2M. Okay. You want me to derive? You can put the comment in the comment section. I can derive it in a separate lecture. Very simple it is, 2 steps or 3 steps. Okay. Otherwise, I am directly, to save time, I am directly just remember that energy is P square by 2M. P is what? Momentum. Okay. And M is the mass. Okay, fine. Because our remaining problems will be focusing on this particular expression. So you can write it somewhere, right? E is equals to P square by 2M. E is kinetic energy. P is momentum. M is the mass, right? Okay. Now from here, we can say that P is nothing but under root 2M kinetic energy. So if P1 equals to P2, as per the problem, if P1 equals to P2, because they are not talking about anything, no relation is between velocities. So P1 equal to P2, I am just writing here root under 2M1 E1 is equals to under root 2M2 E2. Let's square both the sides to remove the roots, and 2 cancels with 2. M1 E1 is equals to M2 E2. Let's cross multiply here. Okay, let's see if this is true or not. So M1 E1 is equals to M2 E2, and one thing is clear is M1 is greater than M2. If M1 is greater than M2, this is obvious that E1 has to be small and E2 has to be large, so then they both are equal. Let me be clear again, once again. If M1 is greater than M2, right? Just imagine any number, just to make it very, very simple. Okay, in layman's language, if M1 is 5 kilos and M2 is 10 kilos, right? To make both of them equal, I have to multiply this 5 with a large number and this 10 with a small number, because 5 into 10 will make it 50 and 10 into 5 will make it 50, right? So you have to be very careful that E1 is less than E2 if M1 is greater than M2. Clear? So let's see if there is such option. E1 is less than E2. Yes, option A is correct. E1 is less than E2, then only this condition is. So why not this one? Let's see this one. So here E1 upon E2, let's find E1 upon E2. So on cross multiplying, E1 upon E2 is M2 upon M1, but here it is written M1 upon M2, which is not true, right? Understood? So here you have to be very careful, conceptual. Great. Let's see the next question. A ball of mass 2 kg. So mass here is 2 kg, fine. And another mass, okay, and another of mass, so let's call it as M1 M2 instead of MB1 M1, and another second ball of mass 4 kg are dropped together from a 60 feet tall building. So let's say this is our 60 feet tall building. From here both the balls are dropped, okay, one is of 2 kg, another is of 4 kg. After a fall of 30 feet, means at 50%, half of this height, towards earth, their respective kinetic energies will be in the ratio of how much? Okay. See, this is very crucial thing. If they are dropped from the same height at the same time, they will have the same velocity when they reach at the 30 feet height. Clear? So let's use the kinetic energy formula. Our kinetic energy formula is half mv square, right? Now, this is very, very important and to understand. No need of wasting your time in finding the velocity at this point for 2 kg and 4 kg. Regardless of what is the mass, the velocities will be same. Sir, why it is same? You have to watch the previous lectures on kinematics, right? There I have already explained you. So let me recall that particular concept, okay? Our velocities will be same in both the cases. Wait, sir. What are the conditions? The condition is they should be dropped from the same height and at the same time, then only the velocity when they reach at 30 feet is same. Sir, what if one is 30 feet and another is 35 feet? In that case, you have to find the velocities. In this case, both has same velocity, same height they are dropped, and same time they are dropped. Okay, this is very crucial. So let's use this kinetic energy formula. So kinetic energy 1 will be equals to half m1v square, right? And kinetic energy of the second particle will be equals to half m2v square. Now they are saying the ratio of both. So when you divide both, energy E1 upon E2 will be equals to half cancelled, v square cancel, m1 upon m2. Now what's our m1? Sir, m1 is 2 kg and m2 is 4 kg. Answer is straight away 1 by 2 kg. Be very, 1 by 2 ratio. Be very, very careful with this. Yeah. Let's see the next question. Great. The next question says a stationary particle explodes into two particles of mass m1 and m2. This is stationary particle. Initial momentum is 0. This is being exploded into two particles m1 and m2. Great. Okay. Which move in opposite directions. They move in opposite directions with velocity v1 and v2. So if this is moving with velocity v1 in this direction, this is moving with velocity minus v2 in this direction. Fine. Magnitude is v1 and v2. Directions are opposite. The ratio of their kinetic energies E1 is to E2 will be how much? Clear it is? Okay. Let's recall our concept of conservation of momentum. Initial momentum will be equals to final momentum. 0 will be equals to m1 v1 minus plus, but the negative sign of the velocity v2 will make it minus. So m1 v1 will be equals to m2 v2. And just now we have learnt m1 and m1 v1 is nothing but the momentum of the first particle is equal to momentum of the second particle. Clear it is? Great. Then the ratio of the kinetic energy. So P1 is just now we have done an expression 2m1 E1 will be equals to under root 2m2 E2. Clear? Momentum of the first particle root 2 me. Momentum of the second particle root 2 me. Just now we have done in the previous problem. Let me square it, remove these 2's, and we left with m1 E1 equals to m2 E2. Where E1 is the kinetic energy of the first particle, E2 is the kinetic energy of the second particle. So E1 upon E2 is equals to m2 upon m1. So correct answer here is ratio of kinetic energies is m2 upon m1. Option A is correct. I hope this is clear. Clear? Let's see the next question. If the kinetic energy of a body is increased by 300%, then the percentage change in momentum will be. Now 90% students, they go wrong here when they apply the concept of error. Be very careful, we are not dealing with error here. We are increasing, okay, so change we are finding, okay, percentage change. Okay, initially let's suppose the kinetic energy is E. So initially is E. Now it is increased by 300%. If something is increased by 300%, we have to add, right? So what will be the new energy? Let me call it as E dash. That will be E plus 300% of E. Now some of you will say, it's a 300%. Is it logical? Let's see here. Okay. So let's see what is the new energy. E will be equals to 3. E plus 3, which will be 4E. Clear? So this is the 300% of the previous value. The new value of energy is 4 times the previous value. Very, very important outcome. Okay. Then the percentage change in the momentum. If previously the energy was E, its value was half mv square. Correct? I hope this is clear. So let's substitute this half mv square here. So our half, when you are increasing the kinetic energy, which means you are increasing the velocity of the same particle, right? So the mass remains same, half m, new velocity of the particles, okay, square, velocity is, new velocity is v dash, 4 times E. What is E? Half mv square. Let's cancel out other stuff. Half cancels with half, m cancels with m, and we left with velocity square will be equals to 4v square. So new velocity will be 2 times the previous velocity. This is the outcome of this 300%. Let me repeat again. The new velocity of the particle is 2 times the velocity of the previous system. Okay, let's come back to this. What is the change in the momentum? So previous momentum was P, which will be mass into velocity. Simple. The new momentum will be P dash, that will be same mass with the new velocity V dash. And what's the new velocity? 2 mv. So this will be m into 2v. So the new momentum will be 2 mv. I hope this is clear. This is the new momentum. They are asking the percentage change in momentum. Sir, how do you calculate percentage change? Delta P upon original P into 100. That will be percentage. What is delta P? Change in momentum upon original momentum into 100. So what is change in momentum? Sir, final momentum minus initial momentum upon initial momentum into 100. Now what is the final momentum? Sir, 2 mv. So 2 mv minus mv whole divided by mv into 100. So this will be equals to mv upon mv into 100, and that will be equals to 100%. So correct answer for this is 100%, option A. I hope this is clear. Clear? So how much percentage of momentum is changed? 100%. Let's see the next question. Our next problem says a particle is projected making an angle of 45 degree with the horizontal. Okay, so theta here is 45 degree with the horizontal, having kinetic energy K. Great. The kinetic energy at the highest point will be how much? So for that we have to first find if it is a projectile. Obviously it has to be projectile because it has been projected at 45 degree, right? So here it is 45 degree. If initial velocity here is u, let's say, so what is our initial kinetic energy? It is half mv, mu square, correct? Now when it reaches at the highest point, I have already explained you this part. When it reaches at the highest point, there are two velocities. The vertical velocity vy becomes 0. Okay, sir, why this vy is 0? If there was some velocity, vertical velocity, it would have gone further more higher, right? But since it is here, the velocity is 0. Since it is not going further more, so hence the velocity is 0. But here we have a horizontal velocity vx cos theta. Clear? So what is vx? Vx is the velocity along x-axis initial, which is u. So u cos theta will be the velocity there. So u dash will be equals to u cos theta. And what is our u? Our u is same, cos 45. And what is cos 45? 1 by root 2. So u by root 2 is the velocity over here at the highest point, right? So what will be our kinetic energy there? So kinetic energy will be equals to half m u by root 2 whole square, correct? So that will be equals to half m u square by 2. So that will be equals to 1 by 2 into half m u square. And what is half mu square? Sir, k. So it will be k by 2 here. Clear? Option B is the correct answer. Let's see our next question. Two bodies with kinetic energies in the ratio E1 upon E2 is equals to 4 is to 1. Great. Kinetic energies are given in the ratio 4 is to 1. Are moving with equal momentums. So P1 equals to P2. The ratio of their masses will be how much, right? So we'll recall our formula. I have already given you in the previous problems, P square by 2m. Correct? We will make use of this particular relation. Okay, and substitute here. So E1 upon E2 is given as 4 by 1. Let's substitute E1. So E1 will be equals to P1 square by 2 times M1. And what about E2? P2 square upon 2 times M2. That's equals to 4 by 1. Correct? Let's cancel out what are the equal parts. P1 equal to P2. Let's cancel out P1 with P2. Let's cancel out 2 with 2. M2 upon M1 it will be this much. M2 upon M1 because M2 will go on the top. So this will be 4 by 1. If M2 upon M1 is 4 is to 1, M1 upon M2 is ratio of their masses will be 1 is to 4. Be very careful. We are finding the ratio of M1 with respect to M2. Okay, that's this, not the option A. Let's see the next one. Great. Our next question says two bodies of mass, first one is M, another one is 4m, are moving with equal energies, E1 equals to E2. What will be the ratio of their linear momentums? Again, we will use the same formula. E1 is nothing but P1 square by 2m1 equals to P2 square by 2m2. Let's cross multiply. So P1 square by P2 square will be equals to 2 cancels with 2, m1 by m2. Correct? Let's substitute the values. So P1 square upon P2 square will be equals to what's M1? M1 is M, M2 4M. Let's cancel out this with this and find the root on both the sides. P1 upon P2 will be equals to 1 by 2. So correct answer is 1 is to 2, option A. Clear? Let's see the next one. Great. Our next question says the kinetic energy acquired by mass M in traveling a distance d. So mass is M. It's traveling by a distance d. Starting from rest, initial velocity is 0. Under the action of constant force, let's call it as F, okay, is directly proportional to how much? Now, kinetic energy is nothing but half m v square, right? Equation 1. Majority of times, students, they directly use the concept. So, kinetic energy is straight away directly proportional to m. We can directly say the answer is option A. No. Here there are conditions which are applied. The condition is we are having a constant force, right? If there is a constant force, let's use the equation of motion, v square minus u square equal to 2as, and s is nothing but d. Let me repeat again. Our equation of motion is v square minus u square equal to 2as, and s is what? The distance d. Clear? Now, initial velocity is 0 as per the question. So, v square will be equals to 2ad. Correct? And acceleration, will substitute this over here. So kinetic energy here will be equals to half m. And what's v square? 2 into acceleration into d. But acceleration is dependent on force, right? How it is dependent on force? Because the force is constant. So we have to express it in terms of that. F by m into d. So this kinetic energy is, in this particular case, is product of force and the displacement. So it's independent of mass m to the power 0. That's the correct answer in this particular case. Clear it is? It's a different case. Let's see the next one. Great. Our next question says two masses of 1 gram. So let's call it as m1 equals to 1 into 10 to the power minus 3 kgs. m2 of 9 gram, 9 into 10 to the power minus 3 kgs. Moving with equal kinetic energies, E1 equal to E2. Great. The ratio of their linear momentum. So if E1 equals to E2, P1 square by 2m1 equals to P2 square by 2m2. Clear? Let's now take cross multiply, cancel out 2 with 2. So you're left with P1 square by P2 square will be equals to m1 upon m2. I hope this is clear. Now this 10 to the power minus 3 will cancel out straight away. So we left with P1 square by P2 square equals to 1 by 9. And P1 upon P2 taking the root will be 1 is to 3. Option C is correct. Clear it is? Let's see the next question. Okay, a particle of mass m, okay, is moving in a horizontal circle. Fine, this is in the horizontal circle like this. Okay, horizontal circle. of radius r. So let's see, this is our radius r with a uniform speed v. Okay, when it moves from one point to a diametrically opposite point. So let's say this is the first point, okay, and this is the second diametrically opposite point. Fine. It's kinetic energy. Let's see what is the velocity here. So velocity here will be v if it is moving with the constant velocity. Here the velocity will be v here. Okay. So its kinetic energy changes by mv square. No, here half mv square and here also half mv square. 0 it will be. Clear. Momentum does not change. Let's see the momentum. Here the momentum, let's say this is our v j cap and this will be minus v j cap, right? If it is diametrically opposite, it will be in the opposite direction, right? So first P1 will be equals to mv j cap. Okay, and P2 will be equals to minus mv j cap, correct? So change in momentum will be delta P will be equals to P2 minus P1 or P1 minus P2. So that will be, you can do anyhow, P1 minus P2 or P2 minus P1. So this will be minus mv j cap minus mv j cap, correct? So that will be equals to minus 2 mv j cap, or the change in momentum magnitude is 2 mv, correct? Sir, why you are saying 2 mv? Okay, because somebody can take a diametrically opposite point at this point and this point also. Okay, you can call it this way, it doesn't make any difference. So we are ignoring the direction, we are just finding the magnitude. So it is 2 mv. So correct option is option C. Momentum change will be by 2 mv. Let's see the last question for today. Great. Our last question for today says a force F is 20 plus 10y acts on a particle in y direction. Great. Where F is in Newton and y is in meter, work done by this force in moving from very simple straightforward question 0 to 1 meter. So we know that work done is nothing but integration from 0 to 1 f dot dy. But sir, I have learned f dot dx. Be very careful. Here the particle is going along y axis, right? And f is also a function of y. So let's straight away do the integration and find the result 20 plus 10y dy. Integration of 20, constant it is. So you left with y from 0 to 1. And here taking 10 outside, integration of y square by 2 from 0 to 1. Putting the upper limit minus lower limit, it will give you 1. And here 10 by 2, upper limit minus lower limit give you 1. So it will be 20 plus 5. So that's 25 joules. Correct answer is option D, 25 joules. Okay. I hope you are getting these problems. We will continue with another lecture on work, power, energy in the next lecture. Clear?